Hey everyone, we're still in 8.1. We're going to finish off the note packet. This is page 7. This one asks us to solve the entire triangle. So we got to find all of the missing angles and sides. So I went ahead and drew it. So we have the picture there. The way I know that there's only one solution here is because that side that's opposite, the 5.7, is bigger than the 4.5. So if that's the case, when you set these up, then you know it's just one triangle. So I could just write what I'm saying there. 5.7 is bigger than 4.5. So that means we have, if you go back to those, it's this one here. I labeled it recently number 3, right? So I have that side that's bigger. Okay, so that means there's only one possible triangle, which is good news. I'm only gonna have one solution. So one triangle. Okay. So let's find it. So my first step on these is let's get that angle A right there. So setting that up, I have 4.5, which is opposite that angle A, over the sine of A is equal to 5.7, the other side given. And then opposite that is the angle of 32 degrees, the B. Okay. And then to solve that, it's cross multiply, and then take the sine inverse of both sides. So you get used to these, you can do that all at once. But if you want me to take that additional step, I would have 4.5 sine 32 equals 5.7 sine A. It's just a cross multiply. All right. And then divide both sides by the 5.7. Okay. And then have that equals the sine A, right? So maybe I'll put the sine A on this side, and then that this over here, 4.5 sine 32 over 5.7, right? So a lot of this is just algebra in a sense. And then finally to get the A, it's going to be sine inverse of all that stuff. And then that's what you're going to put into your calculator carefully. And then what do we end up with? I'll put it up here. So on my calculator, I'm getting about 24.7309. Okay, and this one says round to the nearest degree. So my final answer would be 25 degrees for angle A. Woohoo! Okay, next, then once I have two angles in a triangle, I can get the third angle by the 180 rule. So now I'm going to do 180 minus that 32 that was given minus, and I'm going to be a little bit careful here. I'm going to use the unrounded value, and I'll tell you why in a minute, but just to be accurate, let's see, when I calculate this, I get 123.2691, which in my final answer, when I do the rounding, that's 123 degrees. And there's the C, okay? And then what else do I need? I need the little c. All right, so let's make a little room here. I'm gonna shrink this up and move it over. Okay, give myself some room. And we've got c. Okay, how am I gonna get c? Well, let's just do a law of sines. So that's gonna be the side c over the sine of angle c. And that's why I have that unrounded version of it, just for accuracy in my next calculation. If I just used 123, I might be off by a decimal place, which is going to be frustrating when MyLab tells me I'm wrong. So I'm going to get a little more accuracy. And then the other one that I know that's given is the 5.7 over the sine of 32. Okay. And then now algebraically to solve for c, multiply by the sine of the 123 point blah, 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 and then do that multiplication. So c is going to equal 5.7 times the sine of 123 point whatever, and then divided by the sine of 32. And that should give me my final answer. Calculating that, you should get about 9.0. And we've solved it. Okay. Okay, the next one to solve this triangle, this is the kind where you're going to have two solutions, and I'll show you why I know that. So we're given B 24.5, C 22.7, and angle C 55 degrees. So I always put the given angle my bottom left over here. All right, and then opposite that has to be that 22.7 because that's C. C is always opposite C. And then my other side I always put over here. Okay, so when I'm looking at this setup, there's an H there, the height of that triangle. To see how many solutions I'm going to have, I'm going to find H on this one because the 22.7 is less than the 24.5, which means you might have 2 or 0. And to guarantee or to know for sure, I guess, 24, I'm going to find the height, which is always that side adjacent to the angle times the sine of that angle. Okay, and that height turns out to be, let's see, about 20.1. Okay, so which is less than the 22.7, which means that 22.7 is long enough to create the triangle. And in fact, you can create two triangles because that opposite side, 22.7, is bigger than the 20.1, but less than the 24.5. Which that tells you two triangles. And so I've drawn the other one that if I swing the side over, you'll get this obtuse triangle here. And I just labeled those with sub-2s. But notice with the exact same given information, you can create two triangles, one acute and one obtuse. So we're going to solve each one. Let's start with the acute one, the sub-1s. So I'm looking at that triangle, and I'm going to find B sub 1 to start this off. Right. So I'm going to do 24.5 over the sine of B sub 1 equals 22.7 over the sine of 55. And then the steps, the algebraic steps, are a lot like we just did in the previous problem. So I'm just going to jump right to B sub 1. Right. I know it's going to be sine inverse. And inside is the cross multiply 24.5 sine 55 over that 22.7. Okay. And then I'm going to calculate that on my calculator, and I'm getting approximately 62.1418. You can verify that for me. Let me know if I'm wrong in the email. Okay, and then for my final answer, because it says round to the nearest degree, 62 degrees for my B1. But I do like to keep that written down because I might need it, or I will need it for accuracy when I calculate future measurements. Okay, next we're going to get a sub 1, which is that third angle in the triangle. So I'm going to use the 180 rule. I subtract the 55 and I subtract that 62.1418. And all of that calculates out to 62.8582. I'm doing that right. And then I round that for my final answer is 63 degrees. Okay. Finally, I'm going to find that a sub 1, right? My side here. Okay, I need to get that a sub 1 now. Okay, now I know the angle a sub 1, and I've got law of sines. I can find that. Right? So a sub 1 over the sine of a sub 1 angle, and that's where I need that more accurate one, 62.8582. That's going to be better than 63. That way I won't be off by a decimal place. And then I've got the standard C's 22.7 over sine 55. All right. So then A1, algebraically, I'm going to multiply both sides by the sine 62. I have 22.7 times sine 62.8582 all over sine 55. Okay. And that is approximately, let's see, my calculator, I'm getting 24.7 if I round to one decimal place. And there's my A sub 1. Okay. So that's the acute triangle. We've got all the measurements. All right. Now let's move to the obtuse triangle. Let's get all of those measurements. It's my second solution for this problem. So to bridge between the two triangles, you can figure out B2. B sub 2 is always 180 minus B sub 1, right? Or always start with that angle there. That's the comparison of those two. Okay, and so I'm going to get 180, and then I'm going to try to stay accurate here. So I'm using the one with a bunch of decimal places. Right. So my B sub 2 turns out to be 117.8582. Okay, or if I write my final answer on that is 118 to the nearest degree. Yes, that's B2. Okay, now from that, I can get A2, right? Using the 180 rule in a triangle. So A2 is 180 minus the 55 minus that 117.8582, again for accuracy. So that's going to bring me to 7.1418, or approximately 7 degrees for my A2. Finally, I'm looking at the picture. I'm after that A sub 2 side, law of sines. So A sub 2 over the sine of angle A sub 2, 7.1418, equals back to my given 22.7 over sine 55, using that a lot. And then I'll get my A2 and be done with this problem. All right, so multiply both sides by the denominator, the sine 7.1418, and do that calculation in your calculator. And that should end up being about 3.4. If you want to check me on that. And we got it. Okay, we barely fit that one in. That was a lot of work for one problem. So those are the worst, or the longest, I guess, ones where you have two triangles and you got to solve each one. So you actually end up getting 6 different answers. Okay, moving on. Let's try a application. This is one where we have a flagpole on top of a building. So that's an orange there. From a point on the ground, we're given 2 angles of elevation, to the top of the flagpole and to the bottom of the flagpole. So I've drawn in those angles, and let's find the height of the building, which I labeled X. And so there are 2 triangles in this picture. I labeled them 1 and 2 in purple. Those are the 2 triangles we're going to be solving. So the first step is, let's see if we can find that C, that length of that side. And to do that, we need to find some angles in this triangle. The first one is I'm going to find this angle up here. And that is, if you think about the big triangle, the outside triangle, which is a right triangle, I have 34.8 down here. So this angle is 90 minus that. Right? Those 2 angles have to add up to 90. So I'm going to do 90 degrees minus 34.8, which is 55.2 degrees. So that's that angle right there, 55.2 degrees. Okay. The other angle I would like is this little angle here, which that angle is just the difference between those two angles of elevations. So I'm going to take 34.8 minus 26.4, and that's 8.4 degrees. That's this little angle there. Okay. Now I'm kind of set up. I can find C using law of sines, right? So my little, again, I'm thinking about triangle 1 there, which if I look at that, I have a angle and another angle, and we have the side of 95.3. So that's actually that case. Okay, I guess side, angle, angle, right? Okay, so we should be able to use a law of sines there because I have an opposite. I'm trying to find C. Okay, so C, and then opposite that side C is the angle 55.2 degrees. And then I have the given side, and opposite that side is the little angle of 8.4 degrees. All right. Solve for C. So C is going to equal 95.3 times the sine of 55.2 over sine of 8.4. That's solving algebraically for C. Throwing that into my calculator, I'm getting 535.692. Okay, I'm going to leave that out to some decimal places because it's an intermediate result, it's not an answer. So keeping level of accuracy going here. Okay, now we're going to jump to triangle 2. Triangle 2 is a right triangle, and I know the hypotenuse, and I'm trying to find the opposite. So that's sine, right? Because we have opposite and hypotenuse going back to the first half of this class. So for triangle 2, we're just looking at that as a right triangle. And I'm using the fact that the sine of an angle is the opposite over the hypotenuse. And plugging that in, we have sine. The angle on that triangle is 26.4. And the opposite is x, and the hypotenuse is the C that we just found. Okay, so what is x going to equal? Well, if I multiply both sides by the 535, so I'm going to calculate 535.692 times the sine of 26.4, and that should give me my x. When I calculate that, I'm getting 238 rounded to the nearest foot. And we got it. Woohoo! Okay, so they're solving triangles. Okay, one more page. We have something a little different. It's finding the area of a triangle. There are some formulas you can use when you have the side angle side case. And there's just 3 versions of the formulas, just depending on what sides are given. But all of those are 2 sides and the angle between the 2 sides. Here's an example. We have A, B, and C, angle C. So that matches that first formula. And so it's pretty simple formula to use. It's a little cursive A, so it's not confused with the angle A. And we have 1/2 times 11.7 times 5.2 times the sine of 13.2 degrees. And then you just calculate that. When I put it in my calculator, I just put 0.5 for the half and then calculate that out. And that's 6.9 units squared because it's area. So whatever the units are, it's square units. So if these were in feet, it's square feet, etc. Okay, so that's pretty straightforward. It's a little different if you don't have side angle side to start with. Like in this one, you have 2 angles and 1 side. So I drew that out. I need 2 sides and an angle. So my goal here is to try to find, say, A. I could do B as well, but I want A. For this example, doesn't matter which one. So I do need to get that C, so then I can use law of sines. So my first step is the 180 rule. get C. And so C turns out to be 98.9 here. Okay. And then now I can set up the law of sines to find A. So A over the sine of the angle opposite A is equal to the one side given, which is C, over the sine of angle C, which I just found. And that will give me the A. So it's going to be 25.7 times the sine of 46.2 all over the sine of 98.9 degrees. And so A is approximately 18.775. Okay, so now I've got C and A and the angle B, right? So I have that side angle side. So C and A and angle B. Now I can set up my formula. Let's get that out of the way. So cursive E fancy A, 1/2 25.7 times the 18.775. So the two sides, doesn't matter the order, and then the sine of the angle. And then calculate that out, and you should get about 138.0. And we did it. Whew. Okay, there's the end of 8.1. Hope it made some sense. Send questions my way if you have any, and hope all's well. Talk to you later.